Okay, hi guys again. So, continue our lecture about kinematics. So, let's say we have a scenario in problem solving of a physics problem. We have to have a strategy. Okay? So, the simple way to solve or the simple algorithm to solve a problem is this four important elements. So, the first one is to conceptualize. Okay, so what does that mean? Conceptualize meaning to understand that situation. Okay, so understand the situation usually through graphs. Ano? We have to define the events and so on, and then categorize. So what is categorize? So we have to find a suitable model. We will discuss maybe models later on in the module. But models basically are what are models? No? What are the equations governing this situation? So is this a particle under constant velocity, a particle under constant acceleration? Is this particle at rest? No, and so on. And then after that, if you have a set of equation available, we have to understand what equation to use based on that scenario. So we have a given, we have an equation, we have to find the right equation to solve that problem. Okay, the sequence of equations. Now, after you do that, now, let's say you solve already the problem, you have to check your answer for correctness. Usually, through its values, so you can check if it is in its reasonable ranges. Okay, so moving on, let's discuss the acceleration. Okay. So the acceleration of a given object is defined as the change in velocity over time. So let's say you have a car at rest, for example, and then after a while, it accelerated, to a certain velocity, meaning it changed its velocity from at rest, so zero velocity into some velocity final, which is let's say 10 meters per second. So that difference in velocity is your acceleration. Now, to represent this graphically, we have two types of acceleration, but the graphical representation of their average, let's call this the average velocity, is the difference or the slope of this line connecting these 2 points. Okay, but if you want to find the instantaneous, so we have another instantaneous measurement. The instantaneous acceleration is or any point at this curve, and then find the slope, that is the instantaneous acceleration. Assuming that it's, again, the velocity time curve naman. So again, average acceleration is just the slope, which is the rise over run. So that is the difference in the instantaneous velocities, or actually the difference in the final and the initial velocities over the difference in time. And then for the instantaneous acceleration, again, we have this slope of this tangent to this curve, which is the instantaneous acceleration. Okay? So to find this instantaneous acceleration, that is the derivative. Now, if we're talking about the slope of the tangent line of a curve, that is the instantaneous acceleration of your velocity. So since this is the velocity graph, that will be the velocity. Okay, so be mindful, to add to this, that if the acceleration or the instantaneous acceleration is the derivative of the instantaneous velocity at any given time, then we could say that if this Vx, the instantaneous velocity is equal to the derivative, if we call derivative of the position with respect to time, then therefore we could also say that the acceleration or the instantaneous acceleration is equal to the second derivative of the position function with respect to time. So be mindful also of this additional concept. Okay. Okay, now, this will be a long one. So we have three types of graphs. in representing the motion of a given particle. Ano? So the position time graph measures the position with respect to time, the velocity time graph, so the velocity with respect to time, and the acceleration time graph. So measure the acceleration within the time. So let's say, let's say you have only this given, this one. So the position time graph is given. Can you determine the velocity time graph of your particle? So the answer is actually yes. Okay. So we can erase this now, and then we could rediscover this using the analysis of our curve. Other analysis is this curve if we want to analyze this. What does this mean? We know that the position, okay, or the derivative of the position with respect to time is the velocity, which basically means the slope, no? The slope at an instant. I'll just say this is a slope at an instant. So therefore, if we observe that the slope here is changing, as you can see, so this given point has slope, this given point has a slope, this given point has a slope, and as you can see, the slope is changing in a positive way since the velocity is accelerating. Then we have a change in velocity that is positive and increasing. This means this is increasing linearly. Now, if we observe this interval from A to B, the possession is relatively, the change in position over time, or the slope of this over time, it's not changing now. So the slope here, it's also the slope here, as you can see here. So therefore, the slope here is constant. Therefore, the velocity is also constant. No? So positive yung slope, and then constant. Therefore, the velocity is also constant and positive. Sige, let's write this down. No? So m is increasing, okay, and then positive. So this is increasing also, no? And then as we can see here, this is not really that apparent, but this is actually decreasing, no? So there is some decline at this specific interval. So as we can see here, this interval, the m, no, the slope of this function is decreasing. So this will be true for this, no, also. And actually until this point, it is also decreasing. But let's just imagine this from from point B to point T. So decreasing, and the slope is still positive at this point, no, since the position is still going to the right. Okay, the velocity will be still going to the right since it is still increasing. At least the position is still increasing. The slope is though decreasing. So the slope here is this slope, and then the slope here is actually getting lower and lower, no? So this is another slope. And the decrease in the slope is apparent in this, no? So you can draw this as this line, this straight line, as a decrease, no? A steady decrease in the velocity or the slope. Now, if you can see here, what is the slope of this function? The slope of this function is actually 0, no? So the slope of this function is 0. So therefore, the velocity is also 0. So that is why actually this axis here is equal to 0. And then it will continue to decrease until this point. Okay. So the velocity is decreasing at this point until it turns to the left, no? So at this point, it will go back. As you can see now, the position will go back to its original position. Since the position will decrease, the velocity will now increase, no, towards the left. Okay, so the position of your function is going to the left. And then it will go back for a brief moment, or it will try to stop, or it will decelerate at this point, no? So it will stop its position. So there is a steady decrease, no? So this the m, the slope is actually increasing at this point. And is this positive or negative? So since actually this is negative, no? So to remind you, if this is your slope, this is negative. If this is your slope, this is positive. If it is a horizontal line, the slope is 0. If it is a vertical line, the slope is infinity. So as you can see here, the slope of this line is actually increasing, no? So meaning it is, it is increasing. Sorry, this is the representation, no? Increasing like this. So it is increasing, although the slope is negative. So that is why the velocity is at the negative portion of the graph. And then it will become, so it will, the position will not change. Therefore, there is no velocity. And this slope, no, which is horizontal line, is 0. That is why it is like that. So the same analogy applies for velocity into acceleration. So the acceleration, that is equal to the change in the velocity over time, which is also the slope. So I will leave you to this to analyze. Okay, so one example of this. So the slope is not changing here since it's a straight line, therefore it is constant. And then it's positive. That's why, meaning yung positive natin na nag-increase yung velocity, or the velocity is increasing. Okay, sige, let's move on with a problem. So let's see if we can figure out the instantaneous velocities and the average velocities using these analogies. The velocity of a particle moving along the x-axis varies according to the expression vx is equal to 40 minus 5t squared. And then vx is in meters per second and t is in seconds. So find the average acceleration in the time interval t equal to 0 to 2.0 seconds. So again, if let's say this is the instant, no, at 0 time, and then this is the instant at the 2 time. So your curve is this position function in brown. Then the acceleration, or the average acceleration, is just the slope of the connecting lines between these two. So the average acceleration is equal to this change in velocities over time. So this change in velocity is the final velocity minus the initial velocity over the change in time. So this is equal to, so we have a given here, we have, actually you can compute this, or if the graph already explains this, also we can also do that. Okay, so let's find this anyway, no? Okay, let's not solve this yet. So the VXF, the final velocity, is when the time is equal to 2 seconds, which is this. So we have 40 minus 5 times, so t squared is 2.0 seconds squared. So this is equal to 40 minus, sige, we can just use our calculator. Let's use a calculator. So 40 minus 5 times 2 squared. So 20. So what is the unit? Let's say that this is in meter per second. So this is the final velocity. So the initial velocity is when we substitute the value of t again in this function. So we have 0, no? So this will be 40 minus 50 times 0 squared. So this is equal to 40 only. So substituting this value to get the average velocity. So therefore the average velocity here will be 40, we have 20 minus 40 over, so the final time is 2, the initial time is 0. Okay, so let's move on here. This will be equal to negative 20 over 2, so this is negative 10, right? So negative 10 meter per second squared, so this will be the unit. So what does this mean? So this means that our velocity is decreasing, meaning the acceleration is going to the left. It is counteracting that velocity going to the right. Okay? It means it is decreasing. So determine the acceleration at t is equal to 2.0 seconds. So when we say the acceleration only, we're talking about the instantaneous acceleration. So to find the instantaneous acceleration t sub x, excuse me. Sorry for that. So this is just the derivative of our velocity function with respect to time. So let's find the derivative of our velocity function, which is this. We have 4t minus 5t squared. So this will be equal to, so this will cancel out into 0. So we have negative 10t, right? As our derivative, which is also our ax. So we know that we want to find that t is equal to 2.0 seconds. And therefore, the instantaneous acceleration will be negative 2 times, negative 10 times 2. Then this will be negative 20 meter per second squared. So the graphical representation of that is this tangent line, or the slope of this tangent line. Okay, meaning at this specific instant, no, this particle is decreasing its velocity at this rate. Now it is counteracting that velocity from the right to the left. Okay. So let's talk about the motion diagram. So motion diagrams are important ways to represent your motion in a pictorial matter, in pictorial way pala. Yan. So for this first figure here, letter A, this shows a constant velocity of a car, no, for this example. And what does this mean? So this length of this arrow means that this is the magnitude of your velocity, no, v. So at this case, since the magnitude or the length of this arrow is constant, therefore we could say that the velocity is constant, and it is also evenly spaced. We could also determine the distance between them is constant, no, at these intervals. Now, this car has a constant acceleration in the direction of this velocity. Now, let's say you have a car that is, let's say, from rest, increasing its velocity up to some terminal velocity, for example. We can see the change in velocity gradually increasing over time. And we are assuming here that the acceleration is at a constant rate. Okay, so that the position is changing, no? It is gradually also changing with respect to the change in velocity. And then last one, let's say your car is already moving at a certain velocity, and you press the brakes, no? So it will try to decelerate. So meaning your velocity is decreasing. So the distance between the cars is also decreasing in this diagram. And your acceleration actually will be in the opposite direction. So meaning this acceleration is negative since it is going to the left. Okay? So that's it. So let's discuss this particle, no? or if we analyze a particle under constant acceleration instead of a constant velocity, then we could derive these equations. Now, I won't derive these equations anymore. But guys, please remember the following equations. List them down in your notes, no? To remember, no? Basically, these equations can be derived actually from the analysis that the derivative of the position function is the velocity function. The velocity function, function's derivative is the acceleration, and so on. So integral to the back, no? So the acceleration's area is the velocity or the average velocity, okay? And so on. Alright, so let's analyze this given graphs. And let's match their velocity versus acceleration graphs. So last time we have already discussed this one. So let's do this again. So let's have this dx number, this first figure A. And let's find the respective, it will be this, or this as its paired acceleration graph. So what does this mean? So if you want to find the transition from the velocity function, okay, to the acceleration function, we want to know the relationship of their derivatives. So the derivative of the velocity function is the acceleration, okay? Therefore, the slope, basically, in simple terms, is the acceleration. So as we can see here, what is the slope of this line? what can we say about this? This is positive, no? Kapag ganyan, no? If you have this leaning to the right, this is positive. If this is leaning to the other side, this is negative. Sorry, not that one. Yes, to that one, no? Negative. And then positive is, sorry, 0. And then we have infinity. So this is positive and this is constant. No? So the slope is not changing for lines. We have a constant for lines. So therefore, the answer should be this. So it is a positive, okay? It is positive and it is constant. For letter B here, so the velocity is increasing in a positive manner. So the acceleration should be positive and it is steadily increasing. No? The slope of this graph is steadily increasing. Therefore, there is a gradual increase in acceleration. So therefore, this should be matched to this one. Okay? And then for the last one, say that already this is the answer, no explanation. I'm just kidding. So this will be, as we can see here, the slope here is constant, it is a positive value. And then again, if the slope of this is just, if the function is horizontal line, therefore the slope of this is 0, meaning the acceleration is also 0. So this is the 0 point. Okay, this is positive, this is negative. Okay? So a jet lands on an aircraft carrier at a speed of 140 miles per hour. So what is the acceleration, which is assumed constant if it stops in 2 seconds? It is 2 seconds due to the resting cable that snags the jet and brings it to a stop. So we could imagine an aircraft carrier, for example. Okay, so say this is your aircraft carrier. And then let's say your jet, I think this is enough. So your jet is going through, or going to land through your aircraft carrier. Now it will have this position here. Okay, it will have this position here, this initial position, and then this final position at which it stops due to an arresting cable. So an arresting cable is similar to a slingshot, no? To arrest your motion. So we have here, what we have here, it has an initial speed of, so at this point, we have a velocity, or initial velocity here is 140 miles per hour. Okay? So if it says that it stops, therefore the final velocity here, so bxf, that is equal to 0. Okay, 0 miles per hour, just 0. And then the duration in between these two initial and final velocities is 2 seconds. So the interval. So to determine the acceleration, okay, so since this is a constant acceleration, the average acceleration is equal to the instantaneous acceleration. So this should be equal to, so the average acceleration is equal to the change in the change in velocity, instantaneous velocity over time. So we know that the change in velocity, that is equal to the final velocity minus the initial velocity, and then over the change in time. So the change in time, actually this is also the change in time, no? 2 seconds. Alright, so I'm just not, I will not try to change this anymore. So a sub x, that will be equal to 140 kilometers per hour, no? So we have a problem here, no, actually. We have to first convert. Okay, we have to first convert our units. So to convert 140 miles per hour, what is the conversion, guys? Okay. So we can look at our calculator if we do not remember. So we have here shift convert. Okay. I forgot what is the kilometers per. Let's see. I'll just try 01. Sorry. Convert 01. Okay. I think it is. Let's try another one. 02. Let's try again. Okay, it's getting closer. Shift convert 04. It's getting closer. Somewhere in between. I keep forgetting this as well. Let's say 10. Ah, ayan, Newton ma. Shift convert 09 yata. Mile meter. Nautical miles. We have nautical miles. Shift convert 08. Right. And we have kilometers to mile. Okay, so we have a kilometers per mile conversion. So let's convert this to miles, no? So we have 0.6214. Okay, let's convert this first. So 140 miles per hour. So we multiply this by, so we want to cancel out this miles. We want to convert this one. So the target is meter per second. We will use really CGS. Not really CGS, but MKS system. So we want to multiply this by over MI and then kilometer here. So we will change this first into kilometers before we change into meters. So in 1 kilometer, there is 0.6214 miles. So 1 kilometer is equal to 0.6214 miles. So we can cancel this unit miles. So what remains is this kilometer. So for kilometers, this is easy, no? So 1 kilometer, that is equal to 1,000 meters. And then for the hour, okay, for the hour. So we have 1 hour. Okay, so the quick conversion into seconds is just 3,600 seconds, no? To make things quicker. Or 60 times 60, also 60 minutes, 60 seconds. Okay, so to convert this one, again, we cancel this hours. So what remains here? Kilometer cancel out. What remains is the meter per second. Therefore, what do you call this? The speed in meters per second will be equal to, so multiply everything first in the numerator, multiply everything in the denominator. Okay, so we have 62.58. 62.58 in meters per second. So this is your initial velocity. So therefore, the acceleration here, that will be 62.58 meter per second minus 0 all over the change in time, which is 2 seconds. So the answer here will be, to divide this by 2, the answer will be 31.29. What is the unit? So we have meter per second squared. Okay. Sorry, I swapped this one, no? So it should be negative. It should be 0 nga pala, no? So this is 0. Negative 62.8. Sorry, guys. Yeah. So this should be negative. So what does this mean if this is negative? Okay. So this means basically that your acceleration, the acceleration of your airplane through landing horizontally is going to the left. It is counteracting the velocity. So if the velocity is to the right, v sub x, the acceleration is going to the left. Okay? So that is why it is negative. So it is counteracting that velocity. So if the jet touches down at the position xi is equal to 0, what is the final position? So if we incorporate here the position, let's say this is your xi, this specific point here, what is its final position xf? So we could describe this by utilizing our kinematic equations. No, I did not discuss this, but you should remember this, guys. So the final position x of f is equal to xi. So formula po ito, ano? And then we have dxi plus dxf. And then times time. So we have a given here, given xi, which is equal to 0. This is also given. This is also given. We got the time already. Sorry, this is given. No. So we know that the initial position is 0. And then the initial velocity is 62.58 meter per second. The final velocity is 0. The time is 2.0 seconds. So the final position, that will be equal to, okay, let's multiply this by 2. So this will just cancel out pala, no? So this will just cancel out. So the answer for the final position is 62.58. So what is the unit? So cancel this seconds. We have meters. Alright? So you're driving at a constant speed of 45 meters per second. When you pass a trooper on a motorcycle hidden behind a billboard, 1 second after your car passes the billboard, the trooper sets out from the billboard to catch you, accelerating at a constant rate of 3 miles per second squared. How long does it take for the trooper to overtake your car? So you can imagine this scenario when you are at the expressway, and let's say you are overspeeding. Let's say you are overspeeding, and then let's say this trooper or this patrol person, no, this possibly the police, no, or the patrol group, is trying to catch you for overspeeding. So at after an instant now of 1 second, he will try to overtake you to catch you. So how do we solve this problem? How long does it take the trooper to overtake your car? Now, we could imagine that this given scenario, that the car, okay, so the car here is moving at a constant velocity, okay, diba? And then the motorcycle starts from rest, no? So the initial velocity is 0, and it will try to accelerate at a constant rate until it reaches you. So the point at which you are at the same position, then therefore it will be this overtaking, no? It will start to overtake you. So what is the analysis here? The analysis here, we understood the problem that the final, okay, the final position of your car, okay, is equal to the final position of the trooper, okay, or the police vehicle, no, or the motorcycle. So how do we do this? Okay, this is actually a little bit complicated, but let's break things down. So to find the final position of the car, how do we find the final position of the car? Meaning, their final positions here, XF, will be the same, right? Okay. So this is the XF of both. So this should be equal for both. So to find this final position, we have actually here, this distance can be determined, guys, no? Which is basically just, if this is a constant, no, constant speed, then therefore its position, okay, the position of this is equal to xi plus dxt, if this is constant, no? Now, how do we find the xi? So this xi here is equal to what? So why not this one? Okay. So since the xi here, because it started, or the car simultaneously was in motion when the trooper is about 1 second apart. Kasi 1 second apart yan, no? So therefore, the duration is already 1 second after the trooper has moved on. So there is a distance here. So the distance here, which is also our initial position xi, is equal to the velocity times the time. Okay? So the time here is 1 second. Okay? So xi here is, we have 45 meter per second times the 1 second. So this is this after 1 second. So therefore, this is 45 meters for xi. And then the constant velocity of the car is 45 meter per second multiplied by the time. Okay? So this is for the car. Now, there is problem here actually, no? The car and the motorcycle is at different time scales. Okay, they are at different time scales. So we will assume that the time here, guys, is equal to 0, ano? And this will be negative 1 seconds. When the car, no, this is the trajectory of your car. Okay? So therefore, if you want to find the final velocity of the trooper, assuming a constant acceleration, no, using your formula, we have xi plus bxt times t plus we have 1 half ax t squared. Ayan. So for the t here, it will be at the same time scale if we assume that your xi, no, is this. Okay? Ito yung magiging xi niya. Now, the xi of this motorcycle will be this 0. No? So, this will be your 0 reference point. Okay? So, this will be equal to, so the xi here will be 0. This will, the velocity, since it is at rest, no, initially at rest, so this will be equal to also 0. So this will cancel out, this will cancel out. What is left is this. So what is the acceleration? It's given. This is 3.0, no? And the time is unknown. So we have two unknowns here, therefore this will be 1 half ax, we have 3.00 meter per second squared acceleration multiplied by the time squared of the trooper. Ay! Trooper. Okay, so simplifying this, we have 1.5. Okay, to simplify this, or 3 over 2, no? So this will be 3 over 2 t squared, and then plus 45 t. So I will just set aside the units, guys, no? But through unit analysis, we can see that this will be in meters. Ayan. So plus, yeah. So we have here a polynomial equation in the second order, or a quadratic equation. So to solve for the value of t, for this quadratic equation, so we have 3 halves t squared plus, we have plus 45t, and then plus 45. Okay? And then equate this to 0. Sorry, it should be negative, no? You have to translate this to the other side na pala, no? Okay, manipulation of your variables, this will become negative, negative. So negative here, and actually the outline should be this, no? But we could, the equation is commutative, so I will just put the 0 here to the other side. Yeah. So how do we solve now this equation? There are different ways, no? Factoring, completing the square, or the simplest one, the quadratic formula. Quadratic formula. Okay? Or your calculator, no? So anyways, we can utilize the quadratic formula. So the variable is t, so we have negative b, positive or negative square root of b squared minus 4ac over 2a. So we can solve this using this analytically. So knowing that a here is equal to 3 halves, b here is equal to negative 45, c is equal to negative 45. Okay, using your calculator, there's a quick way to do this using your calculator. You can actually also use the shift calc function. So for the quadratic formula, you can utilize this mode 5, and 3. So ax squared plus bx plus c. So input here the values of a, b, and c. So we have 3 over 2. 3 over 2, we have negative 45, and then another negative 45. So the answer should be 30.97. Okay, so we have two answers actually, the positive and negative. So since we don't have a negative time, no, for this specific scenario, this will be 30.97. So the time here is 30.97 seconds. Okay, so that will be it. See you guys again in the next video.